I'm going to discuss digital differential analyzer line drawing algorithm. First of all, let's try to understand computer screen. Uh, the screen of a computer is a rectangular grid. It is something like this. This is an example. A cell in the grid is called a pixel. One particular cell, we call it a pixel. In this example, we have 20 rows and 20 columns. Okay, 20 rows and 20 columns. If it is a laptop, usually you might have this much of rows and this much of columns. If your vision is sharp, look closely at your laptop screen, then you will see the screen as a grid. Okay, one particular cell in that grid, we call it a pixel. Okay, so in order to demonstrate the algorithm, we use a screen like this. Okay, for the simplicity. And when it comes to hardware, computer hardware, uh, computer hardware can only do lighting up a pixel. Okay, that means if you pass set pixel, if you invoke a method like this, set pixel, you pass something like this, 1000 in your laptop screen, 1000, and then here let's say 500. Okay, then the pixel here in 1000 and 500, let's say somewhere here, this pixel will this method, invoking this method will light up this pixel. Okay, that is the only thing can be done using computer hardware. Okay, all the rest of graphics um, is based on this simple thing. Okay, that means if you want to draw a line segment on your screen, you have to specify its starting point and ending point. Then you have to use an algorithm and implement it to draw the line segment. Okay, so you have to use this method. That is how we draw line segments on the computer screen. Okay, so this is the pseudocode of digital differential analyzer line drawing algorithm. Okay, the best way to understand this is to uh, use an example. Okay, let's consider we specify starting pixel and ending pixel is this one. So we have to draw a line segment from this pixel to this pixel. Okay, so I'm going to draw the part of the screen here. Let's say 3, 4, 5, 2, 3, 4, 5, 6, 7. This is a part of computer screen, and now I have already told you a computer from the hardware level computer can do only lighting up a pixel using set pixel method. Okay, so now we need to draw a line segment from this pixel to this pixel. Okay, so in order to do that we need the assistance of software. Okay, that is why we use this algorithm. Now in this algorithm, void, that means this is not going to return anything. You have to pass 4 integers. That means x1 comma y1, that is our starting coordinates of the starting pixel. X2 comma y2 means the coordinates of the end pixel, this one and this one. Okay, so in order to draw the line segment, we invoke draw 2 comma 3, okay, and then 7 comma 5. And when you use this, now you know this is our x1, this is our y1, this is our x2, this is our y2. Okay, now we declare 4 integer variables and 4 real variables, and here what we have to do is we have to compute 2 values dx and dy. Dx and dy. Let's look at again the example. Now dx means 7 minus 2. 7 minus 2, it is 5. This dy means 5 minus 3, it is 2. Okay, it is our this part x2 minus x1, y2 minus y1. Okay, then what we do is to the x and y we assign x1 and y1. x1 is 2, y1 is 3. Okay, now here you can see it. Then it comes to this part. There what we have to do is you have to compute the absolute value of dx. Absolute value of dx. Okay, this is the absolute value. What do we mean by absolute value? That means if it is minus 5, absolute value is 5. Okay, if it is 5, absolute value is 5. It is 0, absolute value is 0. We ignore the sign. Okay, that is how we compute the absolute value. That means we have to consider the absolute value of dx. Here it is 5. Absolute value of dy, it is 2. Okay, if you look at this condition, now condition is true, no? This condition is true. Therefore, we have to execute this line. That means the steps variable that is equal to the absolute value of dx. That means it is 5. Now let's look at the example. Yes, step 5. And now we move to the next line of our algorithm. There x inc variable we compute, we divide dx by steps. Dx means the value of dx, it is 5. We divide it by 5 is 1. Then we compute y int variable. We divide dy, it is 2 by 5. Now we have 0.4. Okay. Now we compute these two values. Then in our algorithm we invoke this method set pixel round. We have to round. Now here round x and round y. Rounding means to the approximate, to the nearest, to the nearest, we round it to the nearest integer. That means if our number is 3.8, after rounding we will get 4, because 4 is the nearest integer to this number. If the number is 5.2, if we round this number we will get 5, because 5 is the nearest integer to this one. If it is 3.5, usually we know in mathematics we round it to 4. Okay, in this situation we round it to 4. Okay, and now therefore when we round to nearest integer is 2, definitely. Here nearest integer 3 itself. Okay, so now this part will execute the hardware, invoke hardware, and it will send a signal to your screen so that it should light up 2, 3 pixel. 2, 3. This pixel lights up. Okay, now in our line segment, now we have drawn one particular pixel. Okay, now the next part, let's see, we use a for loop. I'll erase this. Okay, in our for loop we begin with k equals 1. Okay, now let's look at the example. Here you can see what I have drawn on the whiteboard, and when k equals 1, what we should do in this loop, x coordinate here you have to now our previous x coordinate. What is our previous x coordinate? It is x1 value, no? X1 value, and previous y coordinate is y1 value. Okay, therefore previous x value is 2. Okay, our previous x value is 2 plus x inc variable, value of x inc variable, that is 1. We add 1, it is 3. Then y variable is 0.4. Okay, here you have to, previous y value is 3, you have to add 0.4, 3.4. Now we use set pixel. We round it, it is 3. We round this, it is 3. Okay. Now a signal will be sent to the screen. We have to light up the pixel T3, 3. This pixel lights up. Okay. So you can see it here. So we move to the next iteration. Okay. So next iteration we move. There we compute x value. Previous x value is 3. We add x in value, then it is 4. Y, previous one is 3.4. We add 0.4. Here 3.8. Okay. Then again set pixel. Round, we have round this one and this one 4, 4. Okay, that means here 4, 4. This will send a signal to a screen, to your screen, and the 4, 4 pixel lights up. Okay, so here I have shown it. When k equals 2, it is something like this. Then let's move to k equals 3. Okay, k equals 3. X, previous x value is 4. Our x inc variable, it is 1. Now this 5. Y, previous value is 3.8. 0.4. Okay, now here 4.2, and then again we invoke set pixel method. There we round it, it is 5. We round this one, it is 4. Then this will send a signal to the computer screen. Then this pixel lights up. Okay, 5, 4. In the example I have shown it when k equals 3, 5, 4. Now again, until the value of steps variable we have to iterate. Therefore, in the next situation, when k equals 4, x, previous value is 5. 5, our x inc variable, it is 1. Therefore, this is 6. If you consider y, 4.2 plus 0.4, 4.6. Okay. Now we have to invoke set pixel method. Here you have rounded 6. Here you have to round it 5. Okay. So the pixel 6, 5 will light up. Okay. In the example, now I have shown it. Then k equals 5. Now value of our steps variable is 5. Okay, until k equals 5 we have to execute this one. Okay, until k equals 5. So the value of x, 6 plus 1, it is 7. Value of y, 4.6 plus 0.4, it is 5. Now we invoke set pixel. We have to round this 7. We have to round this 7 comma 5. So here this pixel lights up. Okay, in that way we can explain the pseudocode of digital differential analyzer algorithm. So now again you can go through this pseudocode and through this example and you will understand properly the digital differential analyzer algorithm. Okay, that's all, and thank you for listening.